we've gotten some practice solving equations. Let's start solving some inequalities. Now, when it comes to inequalities, we're talking about symbols like less than, or greater than, or less than or equal to, and greater than or equal to. Okay? And there's only one rule that we really have to worry about when we're trying to solve any inequality, and that is that when we multiply or divide by a negative number, then we switch the inequality. To illustrate this, I want to take a simple example, like negative x is greater than or equal to negative 1. Now, if we tried to solve this without switching the inequality, what we would do is divide both sides by negative 1, get the two negatives to cancel, and we would be left with x being greater than or equal to negative 1. What that would look like is we would find negative 1 on our number line. Since it's equal to negative 1, we use a dot, and we're talking about all the numbers greater than negative 1. So that would include 0, and 1, and 2, and 3, and so on. Now, if that's true, any of those numbers would be a solution to our original equation. So let's check it. All right. Let's just pick any of those numbers. We can pick 0, 1, 2, or 3. I'm going to let x be 2. Then, when we plug it back into negative x being greater than or equal to 1, that was our original inequality, we would say negative x is greater than or equal to 1 when x was 2. So negative 2 is greater than or equal to 1. Well, looking at our number line, negative 2 is actually over here. Not greater than negative 1, or greater than positive 1, but actually smaller than negative 1. So that is not a solution. So when we are solving these inequalities, when we start off with negative x being greater than or equal to 1, and we do our algebra the right way, we divide both sides by negative 1 to get rid of this negative. We're left with x, and we are left with negative 1, but we have to remember to switch the inequality. Make it point the other way. Now, we still have our negative 1, and we're talking about all the x's that are less than or equal to negative 1. So here's equal to negative 1. All the ones less than that are going to be to the left. So negative 2, negative 3, negative 4, and now we can check just like we did before. We're saying that any of these numbers, negative 2, negative 3, negative 4, any of those are going to be solutions. And to check, I'm just going to pick one. I'm going to let x be negative 3. Then, negative x being greater than or equal to 1 would mean that negative x greater than or equal to 1, where x is negative 3. And the opposite of negative 3 is 3. And 3 is greater than or equal to 1. All right, so the only thing we need to remember is that whenever we multiply or divide by a negative number, switch the inequality. So let's run through a few examples. If we have y minus 6 is less than 3, we want to solve it just like we always would. Since we have minus 6 on the left side, to get rid of that, I'm going to add 6 to both sides. Negative 6 plus 6 is 0. Those cancel, and we're left with y over here. 3 plus 6 is 9 on the right. And should the inequality be the same? That's the only thing we've got to ask ourselves. Did we multiply or divide by a negative number? And all we did was add, so no, we don't switch it. It stays the same. As things get a little bit more complicated, the algebra is still the same. The only thing we've got to worry about is multiplying or dividing by a negative number. So when we have 5w plus 3 is greater than 4w plus 9, you would probably get all of the w's onto one side and get all the constant terms on the other side. So with the w's, 5w minus 4w is w. On the right side, the 4w minus 4w cancels. And for our constant terms, 3 minus 3 cancels, and 9 minus 3 is 6. We didn't do any multiplying or dividing, So that greater than symbol stays greater than. Notice this. What if we started, same problem, but instead of bringing the 4w to the left, what if I brought the 5w to the right? So what I mean is subtract 5w from both sides. I mean, this is math. No matter what way we do it, we should get the same answer. I'm just subtracting, so 4 minus 5 is negative 1w. I'd also take care of the constant terms by getting rid of that 9. So I'd subtract 9 on this side as well. 3 minus 9 is negative 6. So right now I'm at negative 6 is greater than negative 1w. We still have to get rid of that negative 1, and we're going to do that by dividing both sides by negative 1. Negative 6 divided by negative 1 is 6. This time we did divide by a negative number, so we have to switch the inequality. The negative 1's cancel, and we're left with w. And if you compare our two solutions, w is greater than 6, or 6 is less than w. W greater than 6 would mean this. And 6 being less than w, well, we would find 6, and all the w's would have to be greater than, so also off to the right. And we end up with two solutions. Even though they look a little bit different, they are still the same. If we have negative 4.2x is less than or equal to negative 29.4, all we have to do is divide to get that x alone, and we'll have to divide by negative 4.2. Now, if you're not feeling comfortable dividing by a decimal number, that's okay. Grab your calculator and do negative 29.4 divided by negative 4.2, and you'll get 7. On the left, of course, those negative 4.2's cancel, and we're left with x. Since we divided by that negative 4.2, we have to switch the inequality. Let's try one more. Negative 4x is greater than or equal to the quotient of 5x plus 58 and 6. So we'll probably start by getting rid of the fraction, multiply both sides by 6. Right, negative 4x times 6 is negative 24x. And we just multiplied, but did we multiply by a negative number? The number we multiplied here, is this negative? No, that's positive. So our inequality is going to stay pointing in the same direction. On the right-hand side, we're left with 5x plus 58. We still have x's on both sides, so I'm going to remedy that by subtracting 5x from both sides. And we'll be left with negative 29x being greater than or equal to 58. We don't have to worry about switching the inequality because we didn't multiply or divide, we subtracted. But now we're going to divide. To get x alone, we have to divide both sides by negative 29. Those will cancel, so we'll be left with x. And since we divided by a negative number, the number we divided by right here, the 29, is negative. That means we'll have to switch our inequality to less than or equal to, and 58 divided by negative 29 is negative 2. So that will be our final answer. Now, let's make sure that you watch the video all the way to the end. This problem is problem 27 out of your homework. Danielle can hike 3 miles an hour, but she has to take a 1-hour break for lunch and a 1-hour break for dinner. If Danielle wants to hike at least 18 miles, determine how many hours the hike should take. So when we think about what's going on, we've got Danielle here is going to hike for some number of hours, right? And we want that distance from the beginning to the end to be 18 miles. And she can hike 3 miles an hour, but that's only when she's hiking. So what's going to happen is she's going to hike for a while, and then she's going to stop, take a little bit of a break, hike for a while, stop again, have a little dinner break, and then hike for a while to get to the end. So Danielle is hiking 3 miles an hour only part of the time. When she takes those breaks, she's going 0 miles per hour, and then 3 miles per hour, 0 miles per hour. and again, 3 miles per hour. So when we think about distance being rate times time, we recognize that the question asks that Danielle wants to hike at least 18 miles. So her distance has to be at least 18, so it can be greater than or equal to 18. And like I said, distance is rate times time. Her rate is 3 miles an hour. Her time is not X hours because she's not hiking this entire time. She's hiking that entire time except for this 1 hour and this 1 hour as well. So we have to subtract off 2 hours to get our inequality. And now we just solve it like we normally would. To get rid of that 3, since it's 3 times the quantity, I'm going to divide both sides by 3. Since we divided, we got to worry, do I have to switch to inequality? Well, since that 3 is not negative, we do not have to switch it. So we're at x minus 2 is still greater than or equal to. 18 divided by 3 is 6. Finish off by adding 2 to both sides, and we get x is greater than or equal to 8. Now, remember, this is a word problem, and in word problems, numbers aren't numbers, they're measurements. So x greater than or equal to 8 does not actually answer the question. To answer the question, actually go back and read the last statement in the problem. It says, if Danielle wants to hike at least 18 miles, determine how many hours the hike should take. So look at your answer. We've got x is greater than or equal to 8. Determine how many hours the hike should take. We could say 8 hours. Okay? But that's if she was to go exactly 18 miles. She's going at least 18 miles. So instead of answering with 8 hours, maybe say, how many hours would the hike take? It would take at least 8 hours. And that's a good answer to this word problem.